There are a lot of different network types and a lot of different network characteristics. So let's talk about networking types and characteristics. So network types and characteristics, we're really going to be talking a lot about different sizes of networks and how do we reference those. So it's some terminology and wrapping our head around terminology such as what is peer-to-peer, what is the client-server relationship, what is the small office, home office. We'll talk about headquarters versus branch offices, tier 3, tier 2, what spine leaf is, and then we're going to talk about the different LAN and WAN and wireless LAN and MAN and PAN, CAN, SAN, and SDN. So we've got a lot of terminology that we're going to be talking about through this next lesson. A peer-to-peer network is just one that peers are talking with each other, and there's no head to this. There's no centralized location for management of this communication. So in this example right here, we've got several desktops that are set up on the network. One of them has a printer that's hooked up to it, and let's say that printer is shared out. So this machine is sharing out this printer so these other machines have access to it. So there's no centralized location that's managing all of this, but you just set up a share on one machine and the other machines then are able to access that shared resource. Then we have client-server, which is a relationship. A client needs some sort of services versus the server actually distributes those services or fulfills those services. So in this example right here, let's say this desktop right here has several client processes that are running on it. Perhaps one of them is a DHCP or one of them is DNS. So it is needs to make a request to a DNS server. So it makes a request to this DNS server. This server has a process that's running on it that is able to fulfill that request. And so it responds back to the client. So a client is requesting services versus a server is then delivering those services. Then we have a SOHO, or a small office home office. So these are two different things, a small office and a home office, but we group them together because often a small office or a home office has a lot of the same equipment. It has a lot of consumer grade equipment that is on each side of it. So let's say this right here would be a home office. You are working remotely, you're working at home, you have some sort of Wi-Fi router that's on it that your computers connect to. Versus a small office doesn't have a big need for a bunch of separate equipment, a separate switch, a separate router, or big beefy routers, big beefy switches. It just has a simple need, and so we have a wireless router on its side. So we refer that to these two networks that have simplistic needs that usually has consumer grade equipment on it, and it's the small office, home office, or a SOHO. So perhaps you are actually part of a much bigger business, and much bigger businesses has very different needs. They perhaps have much bigger infrastructures that they need to manage. A big business will typically have some sort of headquarters office. So here in Sydney, we have a headquarters office, and that headquarters office facilitates a lot of the main administration of the business. A lot of the CEO or the president of the company probably resides here, and a lot of the financing happens in this main headquarter offices. A lot of the big decisions for the direction of the company happens in the headquarter office. So you have a main headquarters versus some sort of branch office. So here in Brisbane, we have a factory or we have some other branch offices here around the country. And so in this example right here, we have a headquarters and then we have branch offices. And that headquarters is the main administration, but then we have all of these other functions that happen at these different branch offices. So bigger businesses means there's much bigger needs. You have a lot more people that you need to make sure they have connectivity. You have bigger networks that you need to administer. So there needs to be some sort of hierarchy with your structure, and hierarchy that makes sure that you have fault tolerance, that you have scalability, you have quality of service, and security implemented within your network. And so there are structures, like this is an example of a tier 3 network, and you set up a tier 3 network to make sure that you have those components of fault tolerance and scalability, and you can manage your network to make sure you're meeting those employees' needs and the needs of whoever your end users are. So at the bottom layer of this tier 3 network, you have the access layer. The access layer is what your end devices are actually connecting into the network with. So we don't see as much redundancy at this bottom layer because there's not as much of a need for it. Yeah, sure, a piece of equipment could go out, and there are some redundancies that can happen with that piece of equipment, but you probably don't have redundant connections to your different devices. And so because of that, we don't have this big need or as much of a need for this redundant equipment at this access level. Then we have this middle layer. This middle layer is called the distribution layer. This is what's connecting all your access equipment to your core. You'll notice that there's a lot of redundancy at this layer to make sure that your end devices, if something were to go out, the backbone of your network is going to still be up and running. And so that's why we have redundancy amongst this equipment in the distribution layer. Then at the top of this tier 3 system, we have the core layer. The core layer, notice that there's a lot of redundancy within this core layer, and that's because it's the core of the business. Somewhere branched off here, we probably have a connection to all the servers and services that we have here. We've got the branch off to the internet, and we've got redundancy amongst our equipment. This is the biggest, most expensive equipment, plus has the most lines going to our distribution layer. So that's the core of our network. So we talked about one extreme of a small office, home office, and the other extreme of a tier 3 network where you have the core, distribution, and access layers. But there's everything in between. There's so much variety within here. Here's another example of a tier 2 or collapsed. This is where we don't have a big enough network to justify a whole distribution layer, so we combine the core and distribution layer. We still probably have some big pieces of equipment within here, and we still have a lot of redundancy amongst our network. But with this distribution and core combined, we are combining those two layers, and perhaps this equipment is half and half. So the top half of this might have some blades that offer the core services and are connecting to our servers and connecting to the internet, where the bottom half of this within this physical equipment, we have some blades that are offering our services to our access layer and creates that distribution side of it. So this equipment could have that core and distribution in the same equipment, and perhaps it's all mixed up, but usually we like to separate that out and have a core side of that equipment and a distribution layer side of that equipment. Here we have a spine leaf setup. A spine leaf setup, or also called top of rack, is a little different setup where we do still have the core here, but this is mainly used for data centers where we have a lot of racks that are all set up with a bunch of different equipment, and you've got these top of rack switches. The top of rack switches provide network access to all of your servers and are connected to all of the servers. So this aggregates the connections so then it can connect to your core part of your network. So this is a spine leaf or top of rack setup here. Then we have a LAN. A LAN is a local area network. And a local area network, you probably have heard this before. It's just all of the computers that are locally, that are connected together, that are communicating. The key word here is local. So in this example right here, we have a local area network where these devices are all connected to the same layer 2 device. And so this is the local LAN, or the local area network. We add a W to the front of that, and now we've got a wireless LAN. A wireless LAN is just a set of wireless devices that are communicating. So here we have a wireless LAN. All those devices are communicating with each other. They're all local, so that's a wireless LAN. So next we have our WAN. So bringing back the Australia example here, we've got our headquarter office here in Sydney, plus we've got several branch offices here. We need connectivity amongst all of these different offices. And so what we create is a WAN, or a wide area network. A wide area network just links multiple local area networks together to create one larger wide area network. So we talk about this, we're talking about longer distances, we're talking about bigger area. WAN, wide area network. So we've talked about a LAN, a local area network, and a WAN, a wide area network. So what is a MAN, a metropolitan area network? So in our example here with our company, their headquarters is based in Sydney. The WAN is communicating out to all those branch offices, but perhaps in this local city, it has several buildings involved that are spread throughout the city and spread throughout the metropolitan area. Then you create links between all of these different offices within that metropolitan area. Now you have a MAN, or a metropolitan area network. So we've talked about LAN, a local area network. We talked about a WAN. We talked about a MAN. What is a PAN? Well, if you guessed personal area network, you would be correct. So what's a personal area network? It's smaller than a LAN. It's just a device here that's connected to another device. So in our example here, it's a phone connected to earbuds, and it's very localized, so that it doesn't go beyond a certain radius. It's a very small radius, and it's connecting these two devices together. So a phone to some sort of Bluetooth speaker, earbuds, those type of things are examples of a personal area network. Here's another one, a CAN. A CAN is a campus area network. So in a campus area network, just think of it as, it could be a college, or if your headquarters is on a single piece of property, but they have lots of buildings, that would be a campus area network. So think lots of buildings, but still the same property. Then we have SAN. SAN is storage area network. And so I brought back our diagram of the spine leaf, or top of rack. Remember, we had the top of rack switches on here. We have the core distribution. We have some servers that are running on these racks. But we also have this storage, or a storage area network. A storage area network, the key to this is it is similar to other storage, things like hard drives that we have, but the key to this is it's networked. So we've actually have network cables that are running into the storage area network, and then we use some sort of protocol to access that storage on that storage network through our connections, through our local area network. So this is storage area network. So last topic, and then we'll wrap this up. We do have what's called software-defined networking. Hey, like my videos? If you could hit that like button, that really helps me out. So SDN, software-defined networking, is this idea where we have our data centers where we just have a lot of compute power. We have a lot of storage, and we have a lot of networking capability. And so SDN comes in where we can dynamically change this setup and how this communication all happens through software. So it is networking, but we change how things are set up through software rather than through hooking up different pieces of equipment. So rather than hooking up a router, hooking up a firewall, hooking up switches, it's all virtualized, and then it's just all network connect together, and then we put networking, virtual networking components within there, and that's software-defined networking. The networking is defined through software and not hardware. All right, so networking types and characteristics. It's important to know because you'll hear a lot of these terms used throughout networking. And what do they mean? Well, now you have you know what peer-to-peer is, you know what client-server is, small office, home office, these different LANs, wireless LANs, WANs, MANs, PANs, all of these have specific meanings to what they define. And a lot of it has to do with the scope of what it defines and what the radius is of these different networks. So networking types and characteristics.